Okay, in this video we're going to look at combining gravitational potential and kinetic energy. By that we mean we have questions where they are combined. The reason we get so many questions like that is quite often kinetic energy changes to gravitational potential energy and gravitational potential energy turns into kinetic. So if we look at an example of a roller coaster, let's say we have a roller coaster like this, and we have a little cart with some people in it at the top. When the cart goes down this slope, at the top it has lots of gravitational potential energy because it's high up, but as it moves down that slope the height gets less, so the gravitational potential energy gets less. It must go somewhere because it can't be destroyed. So what happens is it gets converted into kinetic energy as it goes down that slope. And then the opposite happens on the way up the slope. The height of the cart increases, therefore its gravitational potential energy increases. That must come from somewhere because it can't be created. So the kinetic energy is changed into gravitational potential energy. So in general, when an object moves upwards, kinetic energy is converted into gravitational potential energy, and when an object moves down, the opposite happens. However, the key thing is we can't break the conservation of energy law. So the total energy in the system must always remain constant. That's the key thing to remember. Okay, let's look at some rather long examples that demonstrate this. So it says a ball of mass 4 kilograms is thrown upwards at a speed of 15 meters per second. So we have a ball that is thrown upwards with an initial velocity of 15 meters per second. It tells it has a mass of 4 kilograms and it asks us to work out its initial kinetic energy. So what we can do here is work out the kinetic energy at the bottom, which is a half mv squared, which would be a half times 4 times 15 squared. Type that into your calculator and you get 15 times 15 times 2, which is 450 joules at the start. However, also at the start we can calculate its potential energy, which is mgh. The height at the start will be 0 if we're assuming it's thrown from the ground. So overall, the potential energy is 0, which means at the start we have a kinetic energy of 450 but a potential energy of 0. And we'll come back to that in a little second. Part B then asks us what is its gravitational potential energy when it is 5 meters above the ground. So we're going to look now at a little time later as that ball moves upwards. It is now 5 meters above the ground. And what I can do is I can work out my potential energy, which is mgh, which is just 4 kilograms, times gravity, which on Earth is 10, times the height of 5, and it gives us that is 200 joules. Now, part C then asks us what is its kinetic energy, and what most people will do when asked that is they will go, I know an equation for that, it's a half mv squared. I know m, do I know v? No, and I have no way of working it out with the information that's just given at the minute that we have. So I can't use that equation here. But what I can use is the conservation of energy, which says that energy cannot be created or destroyed. So if we have a total energy of 450 joules at the start, it must still be 450 joules here. Now, we have 200 joules of potential energy. That can't have come from anywhere. It was 0 to begin with. Must have come from somewhere, and where it's come from is this 450 joules. The ball's going to slow down as it goes upwards. The kinetic energy decreases because it's getting turned into potential energy. Therefore, this has to be 250 joules, so that at this point here, we still have a total energy when we add the kinetic and the potential together of 450 joules. So that total energy doesn't change. Then ask what is the speed when it's 5 meters above the ground. We can then use the kinetic energy equation here to work out the speed. So we do kinetic energy is a half mv squared. By looking at our conservation of energy, we know the kinetic energy needs to be 250. So the half times 4 times v squared, which gives us 125 equals v squared. So the square root of 125 equals v. Type that into your calculator and you get that it is 11.2 meters per second. It then says calculate its maximum height. Well, we know when it reaches its maximum height, as the ball goes up, it slows down, and its maximum height v is 0, which means that its kinetic energy at the very top is also 0. However, the total amount of energy cannot change, which means if we started off at 450, we also had 450 when it was 5 meters tall, the total energy still needs to be 450. The only difference is at the top, it's all potential energy. All the kinetic energy has been converted into potential. We can then use our equation to work out what height that would occur at. So 450 divided by 40 gives you a height of 11.25 meters.